At 8:14 on the morning of October 3, 1954, Chief Pipeline Engineer Donald Harrison stood at the Jumping Pound gas processing facility west of Calgary, watching pressure gauges confirm that natural gas was flowing through a 36-inch steel pipeline that would either prove Alberta could gather and transport gas from thousands of scattered wells to distant markets, or demonstrate that the Western Canadian Sedimentary Basin's vast gas reserves would remain economically worthless despite containing centuries of fuel. 46 years old, 23 years in pipeline engineering, he was supervising the startup of Alberta's first integrated gas gathering system, a network designed to collect gas from production wells scattered across 200,000 square kilometers and deliver it to consumers who would never know their furnaces depended on pipelines buried beneath prairie farmland. The numbers made conventional pipeline engineers skeptical. The system would eventually require 24,000 kilometers of pipe, enough to circle the Earth at the equator. Daily throughput would exceed 15 billion cubic feet, enough gas to heat every home in Canada 3 times over. The network would connect thousands of individual wells to processing plants, then deliver treated gas to export pipelines serving eastern Canada, the U.S. Midwest, and Pacific markets. And Alberta's sedimentary basin contained an estimated 100 trillion cubic feet of recoverable natural gas in formations ranging from conventional sandstone reservoirs to tight gas in the Deep Basin and shale gas in the Montney. But scattered production, wells producing 100,000 to 5 million cubic feet per day from locations 50 to 200 kilometers apart, made gas gathering economically impossible using conventional pipeline economics. The solution wasn't a single pipeline. The solution was a network, an integrated system of gathering lines, trunk lines, and transmission pipelines that would function like the circulatory system, collecting gas from capillaries and delivering it through arteries to distant destinations. Harrison had designed a system based on incremental expansion. The network would grow as production increased, adding gathering lines to new fields while maintaining pressure and flow throughout the existing system. The pressure gauges stabilized at 800 pounds per square inch. Gas flowed. Alberta's gathering system was operational. Western Canada's natural gas industry had begun. The problem started in 1947 when Imperial Oil discovered the Leduc oil field south of Edmonton, triggering exploration across Alberta that revealed massive natural gas deposits in association with oil and in standalone gas fields. The Turner Valley field southwest of Calgary had been producing gas since 1914, but the gas was mostly flared, burned at the wellhead because no market existed. By 1950, Alberta had proven gas reserves exceeding 10 trillion cubic feet, but almost no infrastructure to transport it. Edmonton and Calgary used some gas for heating, but 95% of production was wasted. The federal government created the TransCanada Pipeline Company in 1951 to build a mainline from Alberta to eastern markets. But TransCanada needed a gathering system to collect gas from Alberta's scattered production and deliver it to the mainline at a single connection point. Alberta Gas Trunk Line Company, later renamed NOVA Corporation, then eventually operated by TC Energy as NGTL, was created in 1954 as a Crown Corporation to build the gathering system. Chief Operations Manager Robert Chen, 51 years old, veteran of oil and gas development, led the effort to design a network that could expand indefinitely as new fields were discovered. The design concept was hub and spoke with interconnected loops. In gathering lines, small diameter pipes ranging from 4 to 12 inches would collect gas from individual wells and deliver it to processing plants. Larger transmission lines, 24 to 42 inches in diameter, would move processed gas from plants to pipeline interconnections. Construction began in 1954 with a 36-inch line from Jumping Pound to the TransCanada connection point near Calgary. The line operated at 800 to 1,000 pounds per square inch, high enough to move large volumes efficiently, but low enough to use commercially available pipe and compressors. If you want to see how Donald Harrison and Robert Chen built a 24,000-kilometer network that transformed Western Canadian gas from a flared waste product into the foundation of a continental energy system, please hit that like button. It helps us share more forgotten stories like this. And please subscribe if you haven't already. Back to NGTL. The network expanded rapidly through the 1960s and 1970s as new gas discoveries came online. The Kaybob field northwest of Edmonton began production in 1957, requiring 180 kilometers of new gathering lines. The Rainbow Lake field in northern Alberta started in 1965, adding 400 kilometers. The Deep Basin tight gas fields came online in the 1970s, requiring specialized gathering systems to handle low-pressure production. Chief Construction Engineer William Peterson, 49 years old in 1965, specialist in cold weather pipeline installation, supervised construction across terrain ranging from muskeg swamps to Rocky Mountain foothills. Winter construction was standard. Frozen ground provided stable working conditions that summer's saturated soil couldn't match. The pipeline installation method was conventional, but scaled to unprecedented extent. Crews excavated trenches 1.5 to 2 meters deep, using backhoes or bulldozers with ripper teeth. Welders joined pipe sections using electric arc welding, each joint X-rayed to verify weld quality. Coating crews wrapped completed pipe in corrosion-resistant materials before burial. The system required 110 compressor stations to maintain pressure and flow. Each station housed gas turbine-driven centrifugal compressors generating 5,000 to 25,000 horsepower. The compressors consumed approximately 3% of the gas flowing through the system. Fuel burned to move the remaining 97% to market. Processing plants removed water, hydrogen sulfide, and other contaminants before gas entered the transmission system. The plants operated continuously, processing 50 million to 2 billion cubic feet per day, depending on size and connected production. 2 workers died during construction in the early years. One was killed when a pipe section rolled during unloading. Another died in a compressor station explosion during commissioning. The names: James Morrison, 42, Robert McDonald, 38. The network's complexity increased as unconventional gas development accelerated in the 1990s and 2000s. The Deep Basin, tight sandstone formations requiring hydraulic fracturing to produce economically, generated thousands of low-volume wells scattered across 50,000 square kilometers. Each well produced 500,000 to 2 million cubic feet per day, too little to justify dedicated pipelines. The solution was high-density gathering systems, small diameter lines connecting multiple wells to central collection points, and then larger lines delivering combined flow to processing plants. Some areas had gathering line density exceeding 5 kilometers of pipe per square kilometer of surface area. The Montney Formation in northeastern British Columbia presented even greater challenges. Discovered in the 2000s, the Montney contained an estimated 450 trillion cubic feet of gas in shale and tight sandstone formations, requiring multi-stage hydraulic fracturing and horizontal drilling. Production per well ranged from 1 to 10 million cubic feet per day. But wells were drilled in clusters, pads with 10 to 20 horizontal wells producing simultaneously. Chief System Engineer Michael Chen, 54 years old in 2005, specialist in unconventional gas infrastructure, designed gathering systems that could accommodate rapid production increases as drilling accelerated. The Montney network eventually required 8,000 kilometers of new pipeline and 15 new compressor stations. Today, the NGTL system comprises 24,400 kilometers of pipeline across Alberta and northeastern British Columbia, the most extensive natural gas gathering network in North America. Daily receipt capacity exceeds 15 billion cubic feet, collecting gas from over 4,000 production wells and delivering it to export pipelines, petrochemical facilities, and provincial distribution systems. The system connects to 4 major export routes: the TransCanada Mainline for eastern delivery, the Alliance Pipeline for U.S. Midwest markets, the Westcoast system for Pacific export, and the Northern Border Pipeline for U.S. markets. Alberta's petrochemical industry, producing ethylene, polyethylene, and other chemicals from natural gas feedstock, depends entirely on NGTL for supply. The industry consumes 1.5 billion cubic feet per day, supporting chemical plants at Fort Saskatchewan, Joffre, and Medicine Hat. And Western Canada's natural gas industry depends on NGTL operating normally. A prolonged disruption, whether from compressor station failure cascading through the system, pipeline rupture requiring extended repairs, or cyber attack disabling control systems, would immediately strand gas production at wellheads across Alberta and British Columbia. The system moves 15 billion cubic feet daily, approximately 5.5 trillion cubic feet annually. A one-week shutdown would eliminate 105 billion cubic feet of deliveries and force production curtailment, affecting 4,000 wells. Our gas that cannot be moved must be shut in. Production stopped at the wellhead. The economic impact would exceed $500 million per week as producers lost revenue, compressor stations shut down, and downstream consumers faced supply shortages. TransCanada Mainline would lose its primary gas source. Alliance Pipeline would operate at reduced capacity. Petrochemical plants would curtail production or shut down entirely. The vulnerability became apparent in 2018 when a pipeline rupture near Fort Saskatchewan interrupted flow to TransCanada Mainline for 36 hours. Gas deliveries to eastern Canada declined by 30%. Prices spiked. The incident demonstrated that NGTL has limited redundancy. Most gathering areas have single-path routes to export pipelines. Unlike oil production that can be stored in tanks during pipeline outages, for us, gas production must be shut in immediately when gathering systems fail. Wells cannot produce gas that has nowhere to go. Donald Harrison retired from pipeline engineering in 1972 after supervising NGTL's expansion from a single line to a network covering central Alberta. He died in 1989 at age 81. The gathering system he designed continues operating on the principles he established: incremental expansion, interconnected loops, and standardized operating pressure. Robert Chen retired from operations management in 1980. He died in 1998, aged 99. The hub-and-spoke network architecture he pioneered enabled NGTL's growth from hundreds to thousands of connected wells. William Peterson continued managing pipeline construction until his retirement in 1985. He died in 2003, age 87. The cold-weather construction techniques he perfected became standard for Canadian pipeline projects. Michael Chen retired from system engineering in 2015 after managing Montney expansion. He died in 2022, age 71. The high-density gathering systems he designed handle 40% of NGTL's current throughput. The NGTL system operates 24 hours per day, 365 days per year. Control center operators in Calgary monitor flow rates, pressures, and equipment status across 24,400 kilometers of pipeline. Compressor stations automatically adjust output to maintain system pressure as production and demand fluctuate. Maintenance crews inspect pipelines using inline inspection tools that travel through pipes, detecting corrosion or defects. And somewhere beneath an Alberta farmer's wheat field, the natural gas is flowing through a 36-inch pipeline at 800 pounds per square inch. Gas that started at a well 80 kilometers away, was processed to remove contaminants, then entered a network that will deliver it to a furnace in Toronto, a chemical plant in Fort Saskatchewan, or a power plant in California. All because Donald Harrison watched pressure gauges stabilize at jumping pound on October 3rd, 1954. The system continues. Western Canadian gas production depends on it continuing. If this story moved you the way it moved us, do me a favor, hit that like button. Every single like tells YouTube to show this story to more people. Hit subscribe and turn on notifications. We're rescuing forgotten stories from dusty archives every single day. Stories about infrastructure that connects resources to markets. Real people. Real engineering. A real continental integration. Drop a comment right now and tell us where you're watching from. Are you watching from the United States, United Kingdom, Canada, Australia? Our community stretches across the entire world. You're not just a viewer, you're part of keeping these memories alive. Tell us your location. Tell us if you've worked in pipelines or natural gas. Just let us know you're here. Thank you for watching, and thank you for making sure Donald Harrison, Robert Chen, and the 2 workers who died building this network don't disappear into silence.